So today we're going to go over Newton's laws. Newton's laws of motion. So we're talking about force. The three laws of Newton's are documented. These laws are found to be true, otherwise they're not laws. Remember, laws, when we talk about in science, are things that are proven things of nature. So if you have the laws of motion, these will always happen in nature. So the first law of motion: an object in motion stays in motion. An object at rest stays at rest. So unless something acts upon it, nothing will happen to that object. So something that is in motion will continue to be in motion until something has effect on it. So the tendency of an object to resist any change in motion, which is inertia. That is the definition of inertia. So the greater the mass, the greater inertia. So that means something that is 2 tons is going to be much harder to push to get started than something that is 100 pounds. Same thing with lifting. That deals with gravity, but it's also the same thing with motion. So if you're lifting something up, it's much harder for it to work. So for instance, in this situation, we see the object is staying in motion. So the person or the test tube on the skateboard is continuing to be in motion. Just because the skateboard stops does not mean that automatically stops the thing on the skateboard. So the unbalanced force is the continuation of that test tube once the rest of it stops. So same thing happens if you're not wearing your seatbelt. You will continue to go 70 miles an hour even though the car hits a wall and stops. That's why the seatbelt is there. It's supposed to keep you tethered to the car. Otherwise, you continue to go. That's why seatbelts make sense in laws of science, laws of nature. If you want to live, you wear a seatbelt. All right, second law of motion. And we'll talk about this in our guided practice later too. So this is called the relationship law. So force is mass times acceleration. So it is the acceleration of an object related to its mass. So that is the amount of force is being put onto it. So if the mass increases, then the acceleration decreases for the force needed to change the motion increases. So if you want to push the motion of an object faster and its mass increases, that means the force increases. If your mass decreases, your acceleration increases, the force decreases. So force is directly related to mass, and acceleration is a little bit different. And we talk about this with our triangle, and we'll be using triangles a lot. So the force of an object, the mass is small, the acceleration is large. So force must be much higher if you want to push a golf ball at the same acceleration or the same distance as a truck, because those masses are so much different. So the larger the mass of an object, the more force is needed to stop the object to accelerate. So according to this one, which would you need more force to decelerate? A baseball or a bowling ball? And the answer would be, it depends on the acceleration of the object, but if they're going at the same acceleration, it's going to take much more force to stop a bowling ball than to stop a baseball. So on this one, we're looking at an object will always accelerate in the direction with the most force pushed on it. So the guy in red will be kicking the ball basically through the guy in yellow's foot if they come to it at the same time, because his force is 50 newtons more. So practice problem: what is the net force necessary for a 1,600 kilogram automobile to accelerate 2 meters per second? Well, that's simple. You just multiply the two together. and that gives us 32. And remember, kilograms times meters per second squared is always going to be measured in newtons, because force is always measured in newtons. So if a space shuttle accelerates at 35 meters per second, what is the force of the experienced by the 59 kilogram astronaut? We do the same thing, multiply the two together, and that gives us 2,065 newtons of force. So almost the same amount as what we're seeing, just a little bit less than what we're seeing in the last one. So in this one, if we have a force of 100 newtons and the mass of the sled is 50 kilograms, what is the acceleration being pulled at? We take force divided by mass, and it equals 2 meters per second squared. So that is what your dog is pulling that sled at. All right, third law of motion. Forces always come in pairs. This is known as action and reaction. So for every action, there is an equal and opposite reaction. So as you're pushing away from the wall is absorbing whatever force you're putting on it, which means you are pushing yourself away from it because the wall is taking more force. So same thing when you're walking. You're pushing against the ground, and that is pushing you forward because the ground is not moving. Now, in this one, you see he is jumping from the boat, and because of this, the boat is not a steady force, so it takes less newtons to push that boat backwards and move it than it does to push the wall inside the pool. You see that? So because he's running, he pushes himself away at a certain amount of newtons, and that pushes the boat further away from the dock. And that's it. So you will go through the guided practice on the force boxes and then your force and weight, and we'll go over weight next time. All right.